your pod is not running. It is not crashing. It is not restarting. It's just stuck in creating container state. No logs, no errors, no application. And Kubernetes, it's waiting. But the real question is, what exactly is it waiting for? Hi, I'm Shivam and this is the second video of Kubernetes Debugging Series. Let me show you what's really happening behind the scene. In the last video, we saw crash loop backoff, where Kubernetes keeps restarting your app. But today's problem is completely different. Here, your container never even starts. It is stuck in container creating state. Before a container starts, Kubernetes has to complete certain steps. Pull the image, attach the storage, mount the volumes, inject secrets and configs. If anything in the chain fails, the container never starts. No crash, no restart, just waiting. So let's break this on my kind cluster locally. Before we get started, I have one small request. If you have been finding these videos helpful, I would really appreciate you subscribing to my channel. It's a simple way to support my work and it encourages me to keep creating more contents like this. Now let's jump onto the video. So this is my local cluster. I have one control plane node and two worker nodes. Let's create a secret first. I am using imperative command to create a generic secret called app secret. So our secret got created. Now let's go ahead and we will create a pod. As we can see, the kind is pod, the name of the pod is container demo and it is using an Nginx image. Very simple, nothing fancy. So let's go ahead and we will apply this demo pod.yaml file. So our pod got created. Let's check it. So the status here is running. Everything looks normal and there is no issue. Now let me delete this pod and now let's introduce a real production issue. Now I will create a pod that looks correct but has a hidden problem. So I have already written the pod configuration in the container demo.yaml file. Let's explore it first. As we can see, the kind is pod, the name of the pod is container demo, it is using an Nginx image and it is using some secret which is mounted to a volume. So everything looks correct here. Let's go ahead and we will apply our container demo.yaml file. It says pod created. Let's check it. It says it is trying to create the container. Now watch carefully. The status is container creating. It seems that our pod got stuck. Let's try to run this command once again. It seems like even after a minute, our container is stuck. So this is where most engineers gets confused. Let's think. In our pod, our secret exists. We have defined the volume and we have also defined the mount path. Everything looks correct, but still pod is not starting. Now let's try to check the logs of this container to find out what exactly is happening. Oops, my bad. As we can see, the logs clearly mentions container Nginx in the pod container demo is waiting to start, which means our container never got started. This is the key insight. No logs means container hasn't started. Now let me clear the screen. Let's do a describe on this pod. Let's look at the events of this container. It says successfully assigned default to the kind cluster worker 2 and it says failed mount volume.setup failed for volume secret volume and it says reference non-existent secret key password. So this error means it has failed mount and it could not find the key password in the secret. This is the truth. The secret exists but the expected key inside it does not. Let me clear the screen. Let's simplify what's happening. Before the container starts, Kubernetes validates everything. Volumes, secrets, config maps, and mount paths. If anything is invalid, container never starts. That's why no logs, no crash, and no restart. Just waiting. Container creating is not a failure. It's Kubernetes waiting for dependencies. But it can wait forever. Now let's try to fix the issue. I will update the secret to include the missing key using imperative commands. So as we can see, I'm creating the same secret, but this time I'm adding a password whose value is 123. Now let's apply this secret and let's check our pod. I am hoping after a couple of seconds, the status should change from container creating to running. And there we go. The container is now in running state. So this proves that Kubernetes was waiting for the correct dependency. Now let me show you one more production grade issue. This time the secret exists, the key exists, the volume exists. Everything looks correct, but Kubernetes still cannot start the container. This usually happens when teams mount certificates, tokens, license, files, or credentials as files inside the container. First, let me delete my old pod. So our container got deleted. Now let's create a proper secret. Again, I'm using imperative command to create a generic secret called TLS secret, and these are the two values. So let me go ahead and apply this command. So our secret has been created. Let's explore the file permission demo for this pod. As we can see, the kind is pod, the name of the pod is permission demo, and it is using the same secret name what we created earlier. So let's go ahead and we will apply this file. It says the permission demo is invalid. Invalid value 999 must be between this. So this is something. So this is a very good error which we encountered. It says the default mode value 999 which I gave is invalid and the number should be between 0 and 777. So here Kubernetes does not even try to create a pod. This is different from container creating state. The API server rejects the YAML immediately because secret volume file permission must be between 0000 and 0777. Hence, we got this error. So let's go ahead and we will fix it. Let me make it 0777. I hope it will work this time. Okay, our pod got created. Let's check it. Let's wait for a couple of seconds for our pod to be up and running. It seems that our pod got stuck. Let's try to get the pods again. It seems that our pod is stuck in container creating state. Let me clear the screen and we will check the logs. The logs doesn't give any information to us. It is just saying it is waiting for the container to start. Let's try to do a describe on the pod. Let's check the events. It says mount volume, failed for volume, TLS volume, secret TLS secrets not found. Strange, we created the secrets. The secret what we created is TLS secret, but the name what we specified in the pod is TLS secrets. So that's the reason. So let's go ahead and edit our secret name in the pod. Let's clear the screen and we will reapply this file. It says our pod was deleted and replaced. Let's check our pod, and this time our pod is up and running. So let's check the events for this pod once again. And this time we can see it successfully pulled the image, the container was created and the container was started. So everything worked perfectly. So in our case, it was not a missing secret, it was not a missing key, neither it was a bad mount configuration. It was simply a typo. So container creating usually means Kubernetes is preparing the environment around your container. Image, volume, secrets, config, and network. If that preparation fails, your app never even get a chance to start. In production, this happens due to secret key mismatch or config drift between environments or partial secret updates or Helm values mistake. And the dangerous part is everything looks correct at first glance. And that's why engineers waste hours debugging the issue. Always remember, start with kubectl describe pods and check the events. So now you understood something critical. Not every failure is a crash. Some failure happens before your application even starts. Container creating means Kubernetes is waiting and your job is to find what dependency is blocking it. But here is the next challenge. What if Kubernetes doesn't even try to start your pod? What if it refuses to schedule it at all? That's even a deeper problem. Pending pods. In the next video, I will show you why Kubernetes sometimes refuses to run your pod, even when your configuration looks perfectly valid, and how CPU and memory requests controls everything. That's where real scheduling decisions happen. I will see you in the next one. Till then, keep learning.